Whether you're using REST, parts of REST, or just designing your own set of APIs without any concern for REST, you should try to make appropriate use of HTTP verbs. Doing so will improve the consistency and ease of use of your API and may improve its performance and security as well. Browsers make GET requests to fetch web pages, and within most pages, they also request additional resources using more GET requests. GET requests should be read-only, cacheable, and side effect free. The second verb is POST, which web pages sometimes use to submit data using forms. Used properly, a POST request should communicate to the server that it needs to create a new resource with the information provided. To make updates to existing resources, the PUT verb is used along with a representation of the resource. It's expected that the representation be the complete state of the resource and not just a subset. To remove a resource, the delete verb is used. And if you wish to make an update to only part of a resource, you can use a patch request and only specify the portion of the resource you wish to update. You should avoid using these verbs in non-standard ways. If you design your API to leverage existing HTTP verbs in a standard and consistent manner, your API will be easier to understand and more compatible with developer tools designed to work with APIs. Another occasionally used verb for web APIs is head, which is used to return just header data for a resource and can improve performance by preventing the need to return the entire resource. The options verb can also be useful as it provides a lightweight way to get information from the server about the kinds of requests the server supports. There are many more verbs, but these 7 are the main ones used for building and consuming web APIs. IANA defines at least 39 different verbs in its method registry, if you're interested in learning more. The vast majority of web APIs only need GET, POST, PUT, and DELETE. You may find patch, head, or even options useful as well for certain optimizations, but you should avoid using less common HTTP verbs unless you have a compelling need to do so, as many API clients and tools are unlikely to support them, and many developers will be unfamiliar with them. We are going to focus on the 4 primary verbs of GET, POST, PUT, and DELETE, as well as patch, in this course. As we talk about these verbs, I want you to keep this phrase in mind. In Hypertext Transfer Protocol, idempotence and safety are the major attributes that separate HTTP methods. So, what exactly are idempotence and safety in this context? Idempotence is a somewhat esoteric term that you probably don't use in everyday conversation. However, it's a concept that is useful to understand and apply in the context of web application development, and especially for web APIs. RFC 2616, part of the HTTP 1.1 protocol, defines idempotence like this. Certain HTTP methods are said to be idempotent if, aside from error or expiration issues, the side effects of one or more identical requests is the same as for a single request. Idempotence cares about the state of the system, not necessarily the response sent back by the operation. For example, a delete operation with a unique identifier will result in removing a resource with that ID if it exists, or doing nothing if it doesn't. In either case, the end result in terms of the system state is the same, even if those 2 operations were to return different responses. Wikipedia states that idempotence is the property of certain operations whereby they can be applied multiple times without changing the result beyond the first application. A good example of this property in the real world is elevator call buttons, which typically do not behave any differently if you press the button once or many times, even though sometimes it is satisfying to do so when you're in a hurry. Reading data typically has no side effects at all, so queries should typically be idempotent. In fact, queries are a special case of idempotent called nullipotent, because they should have the same impact on the system, that is, no impact at all, whether they are made 0 times, 1 time, or many times. Unlike pushing a call button for an elevator, which has the same effect whether you do it 1 or more times, looking at the clock has no side effects whether you do it 0 or more times. Methods that do not alter the state of the system should be considered safe for users to interact with. The convention has been established that GET and HEAD methods should not have the significance of taking any action other than retrieval. Safe methods can be used by users freely, and any side effects they might have should not be considered the user's responsibility, since the convention is that such methods should not have any. Safe methods can be used by users without risk. They can also be pre-fetched by user agents to improve user experience and web application performance. Safe endpoints can be cached aggressively, since safe methods have the same effect on the system whether they hit the server or not. Think about which links on a website would be safe for the browser to pre-fetch or a web spider to follow. Links to read or view other documents or pages are typically just fine, but clicking on links or buttons with labels like delete or buy now or checkout are probably much more likely to cause problems. Remember, idempotent means that the operation can be repeated without changing system state, while safe means that it does not change system state. Okay, so to wrap up, idempotence means it can be repeated without changing the state of the underlying system, and safe means it's not changing the state of the system. That gives us this simple reference table showing the different methods and whether or not they're idempotent or safe, or both. GET requests should be read-only. They shouldn't change state. They should be repeatable and cacheable. POST requests create new resources. They change state and should not be repeated, since doing so would create additional, possibly duplicate resources. PUT requests put the system into a specific state. Making the same PUT request once, twice, or many times should have the same impact on the system. But it does change state, so it's not safe. Delete, like PUT, should yield the same system state whether the request is made 1 or more times. It changes state, so it's not safe. Patch is just a more limited version of PUT, and as such has the same characteristics. And head is another read-only operation like GET, which should be both idempotent and safe. Review this table and be sure you know it. It will help a lot when you're considering which verb is most appropriate for a given operation you're designing. POST and PUT are similar in that they each alter server state and typically send data in the body of the request. However, POST is all about adding new resources, while PUT replaces the details of an existing resource. You should typically design your routes so that POSTs are made to the collection resource and PUTs are made to a specific single resource. If you are generating keys on the server, such as with SQL identity columns, then your POST request typically should not include an ID value in the route or the body. Your PUT requests need to specify the ID of the resource they are targeting, and they may do so in the route, the body, or both. Ideally, a PUT request body should include the entire state of the resource being updated, including its ID value. However, the ID used to look up the correct resource should typically come from the route, not the body. And assuming the ID exists in both locations, they should match, otherwise the client intention might be misinterpreted. Some systems will allow the changing of IDs, in which case, if the route contains one ID and the body contains another, then the system would attempt to perform an update that would include updating the ID to the new ID found in the body of the request. Remember, if you only want to update part of a resource, the patch verb is more appropriate. Now let's look at a demo showing the use of these different HTTP methods on certain resources. I'm going to be using the Postman tool. I have it configured using my localhost environment, so the host variable is going to be pointed at localhost:7094. When we go into this collection, you can see that I have a set of different verbs for post, put, get, patch, and delete for the author's resources. So let's start by looking at what happens when we make a simple GET request. First, you might see an error in Postman saying that you can't verify the certificate. This usually happens just the first time that you run it. You can disable SSL verification, and from that point you should be able to get the results to work as expected. Here you can see that I am getting back some results. This is some test data for this system, showing you different IDs and names and Twitter aliases. If I want to get a specific ID, we can go here, and I can specify the ID as a key value in the path for this :ID here. And here I'm looking for author 2. So we'll go ahead and send that. And you can see it works. We get back a 200 OK response with the payload. If I want to create a new author, I can do that. I can come into the post, I can modify the body to specify who that is. And then when I submit that, we get a 201 created. And in this case, it's showing us the body as well. But if we look at the headers, we can also see that it is giving us a location header, showing us where to find this resource. It is under authors 8. If I come back here and we change this to be authors 8, we should then be able to get that resource. We can delete a resource, same idea. Let's delete resource 8 that we just created. In this case, we get a 204 no content telling us it was successful. If we look at our full list once more, we should see that there is no resource 8, which we do. We can issue a put request to change how something works. So we can come in here and change, we'll say ID 2 to be Steve Ardelis Smith, and make sure that our ID matches here, and we'll send that. And now we see that ID 2 has been updated with that new value. Finally, we can issue a patch. A patch is a way to do a partial update. And so in here, we can specify what value we want to replace for a particular ID. So let's go back to number 2, and we're going to change that to make it so that the Twitter alias is Jay Lerman. We'll send this. And now you can see that we've updated just the Twitter alias on ID2. And if we see the full list again, ID2 previously just said string as its values, and now it has my name and Jay Lerman as the Twitter alias. So that is just a quick overview of how the different HTTP methods should work with your resources and what the general CRUD operations should be implemented as using web APIs.